Okay, this is Miss Webb, and this is the second half. I still am on the previous table, though. I forgot one question about it. So we're still on the male and female and whether they participate in after-school athletics. This question is: a randomly selected student participates in after-school athletics programs. So if I look at definitely a random student that participates, I'm looking at this column, and I want to know what's the probability that the student is female. And you would see that's 232 over 400, which is equal to 58% or 0.58. Okay, now they want to know using, here, I'll go to the next slide because it does it nice and pretty for me. I want to know using only your answer from part A. What is the probability this student is male? Okay, so I know that they're either male or female. So if it's female is 0.58, then if it's male would have to be 1, because the most it can be is 100%. 0.58, 0.42 is the probability that it's male, or 42%, because you can't have above 100%. You also know, well, this has got to be 168 over 400, which is equal to 0.42. Because I know that 232 and 168 have to add up to 400, and that would be 400 over 400, which is 100%. They want to make sure that we pointed that out to you. Okay, and they put it nice and pretty for us. Okay, now I want to go to this table that I kind of already know the answer. Okay, so they give us a table of people, students that have asthma, students that do not have asthma. If they have no members that smoke, and if they have members in their family that smoke. And they want to know if these two events are independent. It says if I randomly select a student that has asthma, and if I randomly select a student that has a household member who smokes. Okay, now they have some really long answers. I put it all on one slide because I thought it actually made it easier to look at. So the question is, are these two guys independent? Okay. Now remember, the definition is independent is if I have an event, okay, and I have the same probability for the conditional event, then I know they're independent. So if I had a student with asthma, and then I did the probability that they have no smokers, and if I did a student without asthma, and the probability of no smokers, that was the same. If it was the same, I could say they were independent. That those two events were independent. Okay? Now, same way as if I come down here and I say, okay, I'm going to look at students that have no smokers in their family and see how many of them had asthma. What's the probability that they have asthma? Or I could look at students with smokers in their family and what's the probability that they have asthma. If these were the same, then I could say those events were independent. This is how I could use my conditional probability to tell if two events are independent. Okay, so let's go look at this. A student with asthma, so I'm going to pick a student with asthma that has no, okay, let's get all the students with asthma. Here's all the students with asthma. And I'm going to say they have no smokers. So that's why it's 69 no smokers out of total. You're only picking students with asthma. That's my probability. Okay, so do you understand if you looked at the table before between male and female? So again, you could think of it as I'm looking at the females, I'm looking at the males. Okay, and remember when they did it, they had the same event here and they got the same probability and it was independent. But I'm pretty sure I'm going to get a different probability here. Okay, now if I go look at all the students that do not have asthma, they're on this row. And I want to know the ones that have no probability with no smokers. So I would get 473 over 755. Ooh, the probability that they have no smokers in their family is 62%, or 0.62. So I could definitely say that those two events are not independent. I could also do it the other way around. So let me clear this. Okay, and I could say, okay, I'm going to look at people with smokers and without smokers. So here are the students without smokers. Students, at least one household. Okay, this is with smokers, sorry. This is without. I keep getting those mixed up. I'm going to put without up here. And with. Okay, and I want students without smokers, that's this group here that has asthma. It would be 69 out of 542. There's my probability. Now, if I could go and say, okay, the students with smokers that have asthma, if that probability was the same, I would have independent events. But 113 divided by 395 does not give me the same. So go back and look at that first table, and you can kind of see how it's actually kind of neat that you see that was an independent one, and no matter how you do the numbers, the probability was always the same. But in this case, they're different. They're not independent. Okay, based on the probabilities you calculate in exercise 8, are these two events independent or not independent? They're definitely not independent because the conditional probabilities need to be equal for the events to be independent. Okay, second one. Is the probability, and here I have to do this, no household members, this is without, and this is with. Says, is the probability that a randomly selected student who has asthma and who has a household member who smokes the same or different from the probability that a randomly selected student who does not have asthma but does have a household member who smokes? Let's do the probabilities. I would say, okay, if I have a randomly selected student who has asthma, there's everybody who has asthma, okay, who smokes, okay, who has a household member who smokes. That would be that one right there. Okay, so that's 113 over 182. And I'm pretty sure that they're not going to be the same as the next one, which is probability that a randomly selected student who does not have asthma, these are ones that do not have asthma, but does have a household member who smokes. There we go. 282 out of 755. Pretty sure they're not going to be the same. And look at it. 113 out of 182. That was the top one. And then this one was 282 out of 755. I think I messed that up. Let's go back and look. 282 out of 75, 113 out of 182. Hey, I got it right. Okay. And they are very different. They are not independent. And that's how I can use my conditional probabilities to determine if something is independent. Okay, a student is selected at random. The selected student indicates that he has a household member who smokes. What is the probability that the selected student has asthma? Well, if you have the selected student indicate he has a household member who smokes, so you pick any student and they have someone who smokes. Okay, and what is the probability that the selected student has asthma? There's has asthma out of 395. You're going to have 113 out of 395.29. This is the conditional probability that a randomly selected student has a household family member who smokes has asthma. Okay. You want to get used to how the data is organized in two-way frequency tables and how you can calculate conditional probabilities. This happens, I guarantee you, 30 to 40% of the problems on the SAT are probability statistics, there's a good chance you'll see a two-way frequency table. You have to know that two events are independent if knowing one event has occurred does not change the probability that the second event has occurred. Doesn't matter whether you pick the male or the female, they both have a 40% chance that they will be in an after-school program. Probabilities calculated from two-way frequency tables can be used to determine if two events are independent or not dependent. Okay, and I put in the exit ticket and the answer to the exit ticket so you could look at one more example of this before you tried the problem set. So good luck.